Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one numerical on angle modulation. The question is, the equation of an angle modulated voltage is V of t equal to 10 sine 10 raised to 8t plus 3 sine 10 raised to 4t. Calculate the carrier and modulating frequencies, the modulation index, deviation and the power dissipated in 100 ohm resistor. So let's do it one by one. Now the question says it's an angle modulated signal. They do not mention whether it is FM or PM. So assuming it to be an FM signal, the general form of the FM signal can be written as Vc sine 2 pi fct plus mu f into sine 2 pi fmt. This sine forms depend upon what is given in the question. Right now in the question both these forms are given in the sine form, so we are using the standard expression also in the similar way. Now I can find all the things one by one. The first thing that we have to find is the carrier frequency and modulating frequency. For that we will do a simple comparison of 2 pi fc with this coefficient of t. Coefficient of t in both the terms will be compared. So 2 pi fc is nothing but 10 raised to 8. This means fc will be 10 raised to 8 divided by 2 pi, and this will be equal to nothing but 15.91 megahertz. If you solve it, it comes out to be 15.91 megahertz. I can easily obtain modulating signal frequency by comparing 2 pi fm, coefficient of t in this second sine term, with coefficient of t here. So that makes it 2 pi fm equal to 10 raised to 4, which is fm equal to 10 raised to 4 divided by 2 pi. And if you solve this, you get 1591.5 kilohertz. So that's the expression you get. So 10 raised to 4 by 2 pi comes out to be 1.591 kilohertz. The next thing that we have to find out is the modulation index. Now modulation index can be found by simply comparing the coefficient of sine term with the coefficient of sine term in the given expression. So you can see we get mu f directly because coefficient of sine term is nothing but modulation index. So we get mu f equal to 3. Next we have to find out deviation. Now deviation can be of two types. Let us find frequency deviation first. And frequency deviation, as we all know, will be nothing but mu f into fm, because modulation index is defined as delta f by fm. So delta f will be mu f into fm. Mu f we have got as 3 and fm was 1.591 kilo, and therefore delta f that is being used in this particular FM signal will come out to be 4.774 kilohertz. So that's the value of delta f. Now one can also find phase deviation. Phase deviation is nothing but delta p. That will be nothing but the maximum value of this phase part, and it is, in case of FM, is equal to the modulation index only. So the phase deviation becomes 3 radians. So because nothing was mentioned, it's better to provide both the values of frequency as well as phase deviation. And finally, power dissipated in 100 ohm resistor will be equal to the maximum modulating signal by root 2 squared. So this is the RMS value, peak value divided by root 2. So RMS voltage square divided by the resistance. Vc, maximum Vc, if I again compare, you can see this is Vc, and in the given question it was given as 10. So this will become 10 divided by root 2 squared and divided by 100, because R is given to be 100. So if you solve this, the power dissipated will be 0.5 watt. So that's the complete solution of this particular question.